Hi guys, in this video we're gonna try to fix this Hantek HDM3055 digital multimeter, bench multimeter actually. And this multimeter was sent to me by James from JFIX YouTube channel. So without further ado, let's see what we can do with this multimeter. Okay, so this multimeter apparently is brand new. It's only that James wanted to adapt this one to have a HDMI output, and he connected an adapter, I believe, or I don't know exactly if he connected or no, but he was trying to do that one, and happened that a little bit of non-paying attention to the display connector, he ripped off a piece of plastic and the display connector was broken, and then he tried to solder a new one. We're gonna see how he soldered it, and suddenly the display was not working. So then he tried to poke around, and then I think he bought a new one, and he decided to keep this one aside, and because it's a really good multimeter, I told him, if you don't mind, I can quick have a look on it to understand what's going on with it. Maybe it's not damaged properly, all the multimeter, and maybe we can adjust it. And anyway, if you bought a new one and better, at least you have a spare there in case of anything might happen and the multimeter that you use it's broken, or at least you have a spare there behind. So this one should come out easy here. Let me try it. Okay, yeah, this one is the part of a PCB board here. You can see even he don't plug it back the display connector, because he told me what was the issue. So we're gonna see first the connector, how he soldered it back, because he said that he soldered the connector. So let's hope that he soldered it properly and there is no any shorts in those very tiny connector pins. So we're gonna look in a minute. Only let me open everything here to be ready that we can operate inside of this multimeter. There is another two screws over here in the sides, the last one over here, and let's have a look how is made up this multimeter. As a chassis, metal, solid, is not aluminium, is metal. Okay, so this is the multimeter over here, and relays, really chunky fuses over there, how you can see, and I think this is all the digital control and display over here. We're gonna put this one aside for now, and we're gonna focus on this one, because we know that let me zoom in a bit. Okay, so he said that he broken this connector before. He sent me some picture as well, was this black part that you remove it in order to put the ribbon cable inside and then lock it in place, and he broke that one to the original connector, and then he purchased a new connector and he soldered it. So this one is soldered by James. So let's have a look how good is the solder done over there under the microscope. Okay, so under the microscope I can see the soldering is made really well. I don't see any bridges there around. Maybe here this end it's really hard to put a bit of more solder on that one to have a much better solid joint. I'm gonna try to do it like in this size. In this one is a very nice solder joint. This one maybe because it's around everything here, like the battery and lots of plastic, maybe that's why it's not made properly. I'm gonna try to do it, and yeah, we're gonna see why this display stopped working. I can see here there is a power supply as well. This is a power supply here, and I think is yeah, it's connected to this one, and I presume is the backlight power supply. we're gonna look at that one also in a minute. So yeah, the soldering is really nice. Apart of a bit of soldering in this corner, I'm gonna try to add it by myself. Let's see if we can remove this one easily without do any damage to this one. Like that I can solder a bit better there. I can see solder it, but a little bit there I can also add it, and then we're gonna put this one back. So I'm going with 300 degrees with the soldering iron and a very thin solder wire to try to add a bit of solder over there. I think 300 is not enough, so let's boost it to 350. Yeah, 350 do better. A little bit of solder over there. We don't want to melt the plastic, we want just to add a bit of better support to this connector there. That looks better right now. Okay, so now let's try to... I already measured all the all the solder joints over here, and I can say that is everything really perfect. There is no bridges, and the continuity exists between connector and the PCB. So I'm gonna say let's try to put this one, power the multimeter, and measure few voltages around. So this is the best shot that I can get in this position, so I turn it on now. You can see there is flashing some LEDs. Here you can see the reflection on this capacitor. So I can measure some voltages around there. So that's the ground over there, and let's see if on the input of this this power supply we have any voltage coming in. So it's coming in through that 0 ohm resistor. So I can see there on display we have 5 volts 0.02, so we have 5 volts, and then we need to see if I can get a chance to measure the voltage on the output for the ribbon cable to make sure that we have voltage on the display coming. Let me see if I can manage to do that one. Should be on this capacitor. So we have same voltage. So this power supply looks like it's coming in 5 and it's coming out 5. I think it's wrong. So if you go now on internet to have a look on this display, because James sent me a link for this display, maybe we can find some details on. So let's have a quick look. So James sent me a link of this display that is compatible with this one. So let's see if we find something on description about this. If you say, so look, we have some here, some things. So 7 chips, white LED is the backlight type. And let's see if it says, so the pin number 1, pin number 2, we know that is a backlight according with these papers here. Let's see if it says how many voltage we need for the backlight. So backlight characteristics, so we need a maximum of 24 volts. So we have only 5 volts there, so something is not working good. Definitely something is not working good over there. So at this point I'm going to try to see if it's something getting hot over there, because maybe that chip, you can see there is a chip next to the coil. So there is coil and chip, so maybe that chip is getting hot. So let me bring my thermal camera to have a look what's going on with that chip over there. Let me turn on my thermal camera. Let's see if I could get a shot here. Maybe now I can zoom out a bit. So let me zoom out a bit as well. So the chip is let me put the plastic on this one to don't do any short around there. So the chip that we are looking for is that one. So yeah, I can see it's getting hot. So I'm gonna point over there. So it's that one where I'm pointing. So yeah, it's that chip is getting hot. You can see there it's hot, really hot, that chip. Look, this one should be a boost converter. It should boost the voltage from 5 volts I believe to 20 volts, something like that, maximum 24 according with the data sheet of that display. And it's getting hot and it's not doing nothing. So we need to see which chip is in case of something, maybe we can figure out from where we can buy one. So in order to understand which chip is that one, we need to go back to under the microscope. So let's try to remove again this front, and let's go back to the microscope to see which chip is that. So that's the chip that we are looking for. So is mentioned there KDDOD, that chip with 6 pins. So is that one, that chip with 6 pins, and it's called KDD0D or OD. So let's have a look if we find something like that and what it is. So KDDOD, I see. Did anything we find here? According to this one, there is nothing. So there is a code 1017 datasheet, but definitely this one is not that chip that we are looking for. It's something else, and there is nothing that we can find. Let's have a look in AliExpress if we can find something with this one. KDDOD boost converter. Let's see. Did we find nothing? Yeah. So what we're gonna do now, because we don't know nothing about this chip, what it is and what we can with what we can swap. So yeah, how you're gonna approach this repair when you have a chip and you don't know what is. At least you know what it's doing. So it's boosting the voltage. So we can do some modifications. So let me show you. So our solution is to install one of these two. These are our boost converters, and they can boost the voltage up to 32 volts. And regulating from this pot, you set up the right voltage that you need. Okay, in order to put this one here, where I can have some space in order that I can put it in and put maybe with some double-sided tape and bring some wires to power this one, and from this one to power the display. Maybe if I put some double-sided tape here, there is not too many components. So maybe I can stick it here somewhere with double-sided tape. I'm gonna chop off this excess pins here to don't short nothing, and I think is the unique way to do. I need to see also how it will gonna fit on the main case to don't touch nothing, but definitely I can try that one, or maybe I can try this one somewhere to double-sided tape it over here, come with wires from the power, and from here go to the display. But the display I need there is a joint over there for the backlight, so I need to undo that joint and come with then the wires separated on the output of this one, like that I can power the backlight. Okay, so let's do that to see if it's fixing our problem. Okay, so let's undo everything here, because we need to take out the board to see how we can solder a few wires around there, and let's do it slowly to don't break nothing over here. Because we don't want to break again this connector. So we need to do slowly. Okay, it's out from the place. Let's get this block out there to don't break it. So a few screws, let me do it fast forward, and we're gonna be back when I have everything undo it. Alright, so this is our display and this is our board. So as I say, for this display I need to desolder this joint over here, isolate it back with some Kapton tape, and come with 2 wires from here to know which one is anode and which one is the cathode. Like that I can solder to the positive and negative on the boost converter. From the board we need to desolder that resistor from the place, like that. We stop powering this one to get hot for nothing over there, and like that we disable all this circuit over there, but removing that resistor. So let's start first removing that resistor. Okay, so let's start applying a little bit of flux around this resistor, because this is the power in. So applying a little bit of flux around this one, and 350 degrees soldering iron, and let's have a look. And here we go, we removed the resistor. So now we disable the power to this circuit over here. So now we can solder there a wire, and from there we can go to our bus converter. We're gonna attach it separately. So this is the most thin wire that I find around, and flexible enough. The problem is I have only black color, so I'm gonna need to know how to do it in order to don't mix the positive with negative. It's gonna be easy for me to understand this ones. So let's solder this wire down there for the positive. Yeah, let's make it shorter a bit, that part of don't do any short around there. So here it will gonna be our positive. Maybe if I come from this side with the wire, it will gonna be much easier for me. Yeah. So we have the positive over there, and let's solder a negative over there on this big patch over there. So another piece of wire, let me make quick. And for the ground we can solder over there a point over there. We are right. So this is gonna be the power for our boost converter. Now let's see where the boost converter can go. Okay, so we know this is the positive and this is the negative. Sorry, I have only this wire, which is very thin. I don't have other colors I need to buy, so can use those ones. At the end I decided to put this one according with the space over there. I can put it somewhere here with some double-sided tape on it. But as I say, first I'm gonna cut this excess leads over there to don't do any short with the board. Okay, so I cut those ones, and now this is input, so V in and G and D, and this is gonna be the output. What we're gonna do next? So the next we need to desolder these pins over there. Okay, so let me remove that. I can see there is a tape over there. I can remove this tape. Let's do under the microscope. I can see we need to remove this tape from here in order that we can get to that solder joints. Okay, and 280 degrees. Let's desolder this joint over here. You don't need too much temperature over here because this one is very thin and plastic. So now what I need to do is to isolate that one first with some tape, and then I can solder two wires over there, and they're gonna go to the boost converter. So let's do also that job right now. Okay, so let's first adding some Captain tape in order to isolate those pins underneath down there. Make sure we're not doing any short between this one and that one. And now we can solder two wires over there. So let me prepare two wires. So in order to distinguish which one it will gonna be anode and which one it will gonna be cathode, I cut one longer and one shorter wire. So longer I'm gonna use it for the anode. The longer it will gonna be for the cathode, the anode, sorry, and the shorter one it will gonna be for the anode. Let's solder first the long one to the anode. It should go here, the anode. Okay, let's get the shorter one for the cathode now. So the cathode is this one, and it's soldered in place. Now let's come with more Kapton tape. I'm gonna put another piece underneath over there. Make sure it's good isolation between these two parts of boards. And now another piece of Kapton tape to stick these two together to don't get broken the ribbon over there. Right, let's keep it flush. Let's put the Kapton tape over here. Make sure it's sticky. Let's put another piece to keep the wires also in place over there. It's good. Looks alright to me. And now we can put it all back. Alright, so you can see down here is the multimeter and then the power supply. I set up already 5 volts, so I'm powering this boost converter with 5 volts. So let's have a look how many volts we're getting on the output. So let me just connect these two pins over here without making any shorts. Okay, so we are getting in 5 volts and on the output looks like it's 5.6. So let's adjust it at least somewhere 10 volts. This one is going low, so in that direction. Let's adjust it to somewhere 20 volts, somewhere like that, or 21. We saw that the display needs maximum 24 volts. I don't want even to give the full brightness to the display, so we're gonna start with 21 volts, and if need, we can increase. So we are in 21.9, 21.5, 21.2, 20, 21. I will gonna leave it like that for now, and I can solder it in place. So yeah, nice boost from 5 volts to 21 volts. Alright, let me zoom out to see what I am doing over here first. So here we go, I'm gonna use some double-sided tape, and I know that here the anode is longer, so you can see I have a longer wire, so I know that that one is gonna be the positive. Here I can see where is the positive and negative, because this is negative that goes to all the ground, this is positive. So this is voltage in and this is voltage out. So here around I saw that there is no too many stuff in the case, so if I put down bottom it will gonna touch the other board that is here. So in the top here I can see that I have some free space where I can stick this one. So definitely I'm gonna put double-sided tape in, even if I will gonna stick on top of those transistors. I don't have any other option, so I have this double-sided tape. I can use it over here, and in order to make sure I will not make short in that one, I'm gonna double it. I'm gonna put another one on the top, and here we go. Just let me have a look which one is the V in and V out to make a sign. V out, V in. So let me put it somewhere there. Double-sided tape, and now we can solder the pins. I forget where is the G and D. Now it's gonna be hard to get it out from there. Let me try to get it out, because I need to understand where is also G and D. I forget to look for that one as well. So V in, G and D. So the G and D is on the bottom, so that one we know. Same as here, V out and G and D. I don't know why they don't print it also in this side. It was better if they was printing also in this side all these informations. So let's start with the V in. So V in, I say the negative is down here on the bottom. So let's solder this one over here. Maybe I can make it shorter just like that. Yeah, so let's get it shorter. This is the ground. Let's thin the wire. Let's thin also the place here. So I said that's the ground. So let's solder the ground to the ground. Right. This one is the positive. So we're gonna go over there. So let's chop from here. Okay, let's thin this wire. Let's thin the pad. Let's solder. And now I say that the anode is the longer wire. So longer wire is this. Anode should be going to the positive and the cathode to the negative over there. Yeah, so we can do short like that, but let's first power and to see if we have there 20 volts. Okay, so that's the best way how you can get a shot with this one to can measure, because it's really hard. I need to lie down on the drawers over there in order to get down here. So I say this is the negative and here is the positive. So let's have a look if we have an output. So you can see we have 21 volts. Okay, so we are sure now that we can connect the backlight for the display, and I'm pretty sure that we're gonna get a good a working display. Let's have a look. Okay, so let's connect these wires, because we saw that is working. The voltage is there, so there is nothing that we can have a problem that will not work. So I say the longest is anode and the shorter is cathode. So I'm gonna go with this one over here, because I say the ground is down on the bottom. So let's shorten this cable over there, and let's solder this wire there. Okay, where I put my solder wire? Always I put away from here. So let's thin the wire, and let's thin also the pad, and let's solder it over there. So we have the ground, and let's now cut the positive, and let's solder in place. So that should be the positive over there. And now I believe we should have a working display, so let's try. Okay, so now is the moment of truth to see if we managed to fix this multimeter or no. So pause the video and leave your comment down below. What do you think, is working or is not working? So let's find out. Alright, I can see the power cable is there. I can see my module is there for the boost with my modification that I did with these wires around there. I focus, yeah, now it's focused. So I can see the wires over there, wires, my module there, because I don't know which chip is that one, so I only disabled the power on it. So if my James will gonna figure out which chip is and he want to change it, you just need to put back that resistor of 0 ohm or a fuse there where I take it out to solder the positive wire that comes to this one. Okay, so now let's just power this on to see if it's working. So you can see display is working fine now. Let's see if it's also responding to the commands. So here we are in DC voltage, AC voltage responding, ohms is responding, frequency counter is responding, continuity mode responding, temperature responding, and yeah, I'm happy that I managed to fix it. And definitely I'm gonna put all the screw backs on the case, everything back to normal after this video, because there is lots of screws to put in this multimeter, so everything wasn't important. We saw it, how to fix in case of that chip blown any of this multimeter. And I have also a message to encourage James. So James, when things go bad in electronics, you can't do nothing. You don't need to disappoint yourself that maybe because of your fault happen. Things happen in electronics. And I'm pretty sure if you was putting your more time around of this multimeter and poking around, I'm pretty sure you was figure out what's wrong with and what happened when you mess it up with the connector. I'm pretty sure when you insert the ribbon cable, because the black plastic was not holding in place the ribbon, definitely short out the anode and cathode for the backlight LED and blow up the chip that do the boost voltage converter for the display. At least we found it, and we know that that one is burned out. If you might find it's easy, you just desolder it with the hot air station and you just replenish with a new one and just replace that resistor of 0 ohm, and it will gonna work on the factory way. But I couldn't understand which chip is that one, so I went on my way to add a boost converter on. If you are interested in any of the tools that I use in this video, check the link on the description down below, and you're gonna find the link for all my tools that I'm using around the bench, and useful things that if you are in this hobby or you are doing repair or you are doing electronics, definitely will gonna help. They will be handy. And if you are also new to my channel watching this video, please subscribe, activate the notification bell to don't miss my next videos. And until the next video, guys, have a good day and bye bye.